The first anomaly, the illusion of free acceleration. At first glance, a gravity assist seems to create energy from nothing. A spacecraft approaches a planet, swings around it, and departs with more velocity than it arrived with. The intuition feels violated. How can speed increase without fuel? The answer lies in the planet itself. The spacecraft is not gaining energy in isolation. It is stealing an almost immeasurable fraction of the planet's orbital momentum around the sun. The planet slows down imperceptibly. The spacecraft speeds up noticeably. Conservation laws remain intact, but only when the entire system is accounted for. Still, something unsettling remains. The energy gain is real, yet the source is distributed across a system so large it becomes effectively invisible. The planet does not feel the loss in any meaningful way. The spacecraft does not pay in fuel. Energy seems to emerge from geometry and motion rather than a direct exchange. This creates the first philosophical fracture. Energy is not a substance, but a relationship between frames of motion. And if energy depends on perspective, then what else might be similarly dependent? The second disturbance: moving reference frames and hidden accounting. Gravity assists only work because motion is relative. A spacecraft gains speed in one frame while losing or gaining differently in another. From the perspective of the planet, the spacecraft's trajectory is simply a curved path. From the sun's perspective, it becomes a dramatic acceleration. This duality introduces a subtle instability in intuition. Energy is not an absolute quantity in the way everyday experience suggests. It is deeply tied to the observer's frame of reference. What makes this unsettling is not the mathematics. It is the implication that free energy is not a violation, but a translation. The universe allows energy to appear or disappear, depending on how motion is described. As long as the underlying bookkeeping remains consistent, it raises a deeper question. If energy is so dependent on perspective, then is reality itself more like a coordinated accounting system than a fixed structure? And if so, who or what is performing the accounting? The third echo: the Oberth effect and the compression of time. When a spacecraft fires its engines near a massive object, it gains far more energy than if it fires in deep space. This is known as the Oberth effect. The closer it is to a gravitational well, the more effective its thrust becomes. At first, this seems like a simple consequence of velocity, but it introduces a deeper strangeness. Timing and location become energy multipliers. The same amount of fuel produces different outcomes depending on where and when it is used. In this way, gravity wells act like amplifiers of potential. Space and time themselves become active participants in energy exchange. The unsettling implication is that energy is not just about force, but about context. The universe appears to reward precision in timing and positioning, almost as if it is optimizing trajectories through a vast computational landscape. And once optimization enters the picture, the boundary between physics and computation begins to blur. The fourth irregularity: multi-body chaos as hidden structure. Gravity assists rely on carefully arranged planetary alignments. Spacecraft like Voyager and New Horizons depended on rare configurations of Jupiter, Saturn, and beyond. Yet the solar system is not stable in a simple sense. It is chaotic over long timescales. Planetary orbits shift subtly, resonances form and dissolve, and trajectories diverge exponentially over millions of years. And yet, within this chaos, windows of extreme order emerge. Brief periods where gravity assists become possible, almost as if the system temporarily aligns itself for transfer of motion. This creates a paradox. Chaos generates structure that enables precision engineering. The universe appears both unpredictable and selectively navigable. It invites a strange interpretation. Perhaps chaos is not the absence of structure, but a deeper form of it. One that occasionally reveals pathways of energy exchange that would otherwise remain hidden.
The fifth distortion: resonance chains and orbital cooperation. Some planetary systems exhibit resonance chains, orbital relationships where bodies lock into repeating gravitational patterns. These configurations allow stable energy transfer over long periods. In such systems, gravity assists are not isolated events, but part of a continuous dance of momentum exchange. Each orbit subtly influences the next. This transforms the idea of free energy again. It is no longer a trick used by spacecraft, but a natural property of orbital ecosystems. Planets and moons become participants in a slow, gravitational choreography. But the deeper implication is unsettling. Energy transfer appears cooperative at cosmic scales. Systems evolve into configurations that facilitate motion redistribution. Why should matter organize itself into energy-sharing patterns? Is this simply statistical inevitability? Or does the universe inherently prefer pathways of efficient exchange? The sixth anomaly: the silence of energy loss.
If planets give up momentum during gravity assists, where is the evidence? The answer is nowhere visible on human timescales. A planet like Jupiter loses energy so minutely that it is effectively undetectable. And yet, in principle, every spacecraft that slingshots past it leaves a trace in its orbital energy budget. This introduces a profound asymmetry. Massive systems carry invisible costs for small systems' gains. The universe allows energy redistribution at scales that conceal their own consequences. The accounting exists, but the ledger is written in changes too small to observe directly. It raises an unsettling possibility. Large systems may be quietly shaped by countless tiny interactions that individually seem meaningless, but collectively define the evolution of motion itself. The seventh undercurrent, information hidden in trajectories. Every gravity assist is a precise geometric event. Approach angle, velocity, timing, all determine outcome. In this sense, trajectory becomes a form of information processing. A spacecraft does not simply move through space, it computes a path through gravitational fields. This suggests a deeper interpretation. Motion is not just physical change, but information transformation. The universe encodes possibilities in curvature, and motion selects among them. At this level, gravity assists resemble logic operations performed in spacetime itself. And once motion becomes computation, energy begins to look less like fuel and more like a measure of informational change. The eighth shift, the edge of escape velocity. Escape velocity is often described as a threshold. Cross it, and an object leaves a gravitational field forever. Gravity assists exploit this boundary, pushing spacecraft just beyond what their engines alone could achieve. But thresholds in physics are rarely absolute. They are emergent properties of systems under specific conditions. The unsettling realization is that escape velocity is not a wall, but a gradient. A carefully tuned system can always find a way to cross it through external interactions. This suggests that boundaries in the universe are not rigid separations, but negotiated transitions between energy states. And if boundaries are negotiable, then the distinction between bound and unbound motion becomes less fundamental than it appears. The ninth implication, cosmic engineering without engineers. Across galaxies, we observe natural systems that behave like optimized gravitational networks. Orbital resonances, accretion flows, and energy redistributions that mirror engineered efficiency. Gravity assists, in this context, feel less like a human invention and more like a discovered feature of a pre-existing cosmic logic. This raises a difficult question. Is the universe simply permitting these pathways, or is it inherently structured around them? Even without invoking intentional design, the appearance of optimization is difficult to ignore. Motion consistently finds the most efficient route through gravitational landscapes. It creates a subtle cognitive tension. Either efficiency is an emergent property of randomness, or randomness itself is constrained by deeper organizing principles. The 10th convergence, the universe as a momentum network. When all these threads are combined, reference frames, orbital chaos, resonance chains, invisible energy costs, and computational trajectories, a larger picture begins to form. The universe resembles less a collection of isolated objects and more a vast network of momentum exchange. Every body influences every other, directly or indirectly, through gravitational interaction. Gravity assists are simply the most visible expression of this network, a moment where human technology briefly taps into a universal mechanism already operating at cosmic scale. And yet, this raises an unresolved tension. If everything is part of a continuous exchange system, then where does individuality of motion truly reside? Is any object ever truly isolated in its energy state? Or is isolation itself just a temporary illusion created by scale? Convolution. Gravity assists, at first glance, are a clever engineering trick, ways to extend missions beyond the limits of fuel. But as the pattern unfolds across 10 interconnected perspectives, they begin to resemble something broader. Not a loophole in physics, but a window into how motion itself is structured. Energy does not appear as something stored and spent in isolation. It behaves more like a relational property, distributed across systems that are too large to perceive in full. Planets slow imperceptibly, spacecraft accelerate meaningfully, and the balance is maintained across distances that dissolve intuition. Yet what lingers is not the mathematics, but the implication. The universe allows energy to be redistributed in ways that feel asymmetric from any single viewpoint. It hides the cost in scale, spreads the gain across motion, and maintains equilibrium in ways that are only visible when everything is considered at once. Perhaps gravity assists are not exceptions, but reminders. Reminders that motion is never truly local, and that every trajectory is part of a much larger, ongoing exchange.
And if that is true, then the deeper question is not how spacecraft gain energy without fuel, but how many other forms of free transfer exist across the universe, unnoticed simply because we have not yet learned how to see the full ledger of motion.